Hey, everybody. Welcome back. My name is Jay Gordon. I'm a senior program manager with the Azure Cosmos DB team, and you are here for the June edition of the Azure Cosmos DB Global User Group. I want to welcome you back. It's always great to see all of you. We've got a great episode to share with you today. I've got a great guest, someone that I can say, a little bit from my previous past in my career. So it's great to have some time to spend with him and spend time with you. I love getting to spend time with you. So please make sure you're part of the show. You're going to have questions. You're going to have comments. You're going to go ahead and leave them in the comment section. And to help make sure that that goes the right way, I have someone to bring in, and that is Askia. Askia, you are with me every time we do these, and you always help get our audience set up to have a great session. So why don't you give our audience a little bit of information on how they can participate and participate safely.
All right. Well, appreciate that, Jay. As Jay mentioned, my name is Askia. I'm one of the event planners for the Redmond Reactor Space. And one of the things that we'd ask that you do is take a look at our code of conduct, which we've also posted in the chat. Basically, what this says is that we seek to provide a respectful environment for both our audience and presenters. We definitely encourage engagement in the chat, but we just ask that you please be mindful of your commentary, can remain professional, and possible, please try to stay on topic. We'll definitely be sharing useful links throughout the chat, so keep an eye out for that. And a big thing is that we want to let you know that this session is going to be recorded and will be available for on-demand viewing in case you miss any of it. And that typically is available 24 to 48 hours after the session is ended. And you can find that on the Microsoft Reactor YouTube channel.
Thank you so much. It's always good to have you. I'm going to see you at the bottom of the show to help me kind of close things out. Thank you so much.
Sounds good. Thanks.
See you then. So, like I said, I have a great show for you. But I actually, before we get started, I want to kind of do a little housekeeping that I have my own. First of all, I want you to check out a new series that we've got. It's a new Cosmos DB and Python video series, and it's covering things around Cosmos DB and fast API applications. I really think it's great. It's done by one of our cloud developer advocates, Gwyneth. I really suggest you check it out. I'll also drop the link in the chat, so you'll be able to get to it from there. And also, I really had so much given in my way, all this information about Microsoft Build and the Azure Cosmos DB presence there. And, I was really impressed how much. And so one of the things that came after was a really good conversation between Kirill, who is our corporate vice president, and Mark Brown, who you may know, he's been around the Cosmos DB world. They had a really great conversation. They went through all the stuff that we saw at Build, but there's a little clip of them chatting about just the explosion of AI and Azure Cosmos DB.
I think what I really liked about Cosmos DB presence at Build is that we've covered end-to-end all aspects of the modern app development. Obviously, we spent a lot of time on AI, and that's on everyone's mind, right? AI really revolutionized the industry. It's disrupting every use case, every scenario, used a lot. Just for the sake of sharing, some background data, roughly 38% of all Cosmos DB usage now comes from apps that use AI one way or the other. That's a staggering number.
That's staggering. When you look back 2 years, that was zero.
Yeah. And it doesn't mean that it's not just like new apps added, but it's also existing apps adopted AI.
That's right, modernizing.
That's right.
Hey, I'm back. So what was the point of showing you that? Well, if you're going to be running an AI application in Azure Cosmos DB, you might need to bring over some existing data. And if that's the case, you're going to need a migration tool to help you through that. And that's one of the reasons why we're here today. And to help us understand a way to bring over some data in, via migration, I'm going to bring in the CEO, founder of Adiom, and make sure you unmute yourself, Alexander Komyagin. We used to work together at MongoDB. It was a great time. We were there during some really cool innovation. And being at Cosmos, I'm also really part of some great innovation. And you're here to help us bring people to Cosmos.
Yeah, Jay, it's great to be working with you again on this. Obviously missed those great times. And thank you for having me here.
Absolutely. So one of the things I want to do before we get into the real technical parts is I'll learn a little bit about yourself. You've got a great background. Like I said, we work together at MongoDB. But why don't you give us a little insight on, your career and how you got to be here today?
Absolutely. And thank you for the compliment on my background. That is my apartment. So I appreciate it. A lot of thought went into it. Just kidding. An airplane joke. I spent about 10 years in MongoDB working on a wide variety of projects, customers, products, and a lot of that time was actually spent working with some of the most complex environments and bringing data or applications onto MongoDB, whether it was from migrating legacy environments or perhaps moving from self-managed to MongoDB Atlas or from different kinds of platforms. And what I saw was that most people assume that it's going to be easy. It's going to be just like moving data from one place to another and it's going to be done. And it was never easy.
No, never easy at all.
That was always an ambush for even very sophisticated technical teams. We will talk about some examples later. So last year, I left MongoDB. I started my company Adiom, and one of our big goals, a mission, is to make data interconnectivity really easy. Make it so easy and reliable that a migration from one platform to another would be just a no-brainer.
Yeah, well, I've always found that database migrations are some of the more terrifying types of migrations that are out there. And, there's so much planning that has to happen. There are so many different variables that come into play, making sure you're capturing all the updates that happen and as close if you have to do an online migration, making sure that, you're able to cut over properly, even in an offline migration, all these things that are super, super important. And so you're going to help us understand using the Adiom tool, how we can bring over some data from, say, another cloud into Azure Cosmos DB. My dog is hanging out here. He's kind of unhappy. The super's upstairs doing something, but you lived in New York. You understand how it goes.
Yeah.
Cool. So I want you to show me what you've got to. So I'm going to bring your presentation up, and then I'm going to give you the floor. If you're watching on the stream, you have the chat, YouTube. Please leave me a message, comment, question. I'll get it to Alex as soon as I can. With that, have at it, Alex.
Yeah, thank you, Jay. Again, thanks everybody for joining for this conversation. I will try to keep it conversation style, even though I cannot hear you, but you can relay your comments to Jay and he can plug them in. Really don't want to make it a lecture. Here we will talk a lot about why migrations are painful, and we will talk a lot about how to make them less painful. For those of you who already done large-scale migrations, you know that this is never just move the data. This is planning, etc., data validation, And those things can take from weeks to months and sometimes years. And we will talk about how to keep those timelines tight. And lastly, we will talk about the solution that we are working on at Adiom, which I hope you will find interesting. At Adiom, we partner with Microsoft specifically on migrations from MongoDB to vCore, which is the newest offering with MongoDB API that they have, and migrations from DynamoDB to Cosmos DB for NoSQL. But today's presentation is really going to be like more abstract, but the demo we'll see later is DynamoDB to Cosmos DB for NoSQL. So first of all, why migrate to Cosmos DB? I think this is very important to understand that Cosmos DB is not just a database. Cosmos DB is an integrated offering in Azure ecosystem. Comparatively to running a database self-managed or on-prem, by using Cosmos DB, we've seen customers benefit from integrations into their identity ecosystem, AI features, data fabric, and a bunch of other cool stuff that they have. Specifically, NoSQL and vCore have some interesting capabilities. They have native vector indexing, which allows them to store vector alongside the data instead of in a separate index. They have SQL-like interface for NoSQL, as opposed to DynamoDB that has a proprietary interface. And for vCore, they feature decently compatible and continuously improved MongoDB API. Overall, I would say that they also have a lot of interesting features that concern reliability. For NoSQL, they have very flexible consistency levels. They have latency guarantees, availability guarantees, and for vCore, it's very important to see that they have a very good TCO and even an open source version. Now, as we said that Cosmos DB is worth considering at the very least, how do we get there? And on a very high level, the steps are pretty self-explanatory. You plan, you test, you execute. One step that a lot of people don't do but probably should, they need to dedicate time to post-migration optimization. A lot of folks, they assume that once you move from one place to another and you've done your experiments and maybe some load tests on staging, then things are going to be good. It is rarely so. It's almost always in production. There is something different going on, something not represented in staging or in load test. So you do need to dedicate a few weeks at the very least for continuous monitoring and optimization post-migration. How do we improve this process, and why do we need to improve it? This is a pretty loaded slide, so I will go into some details here. So the challenge with this high-level process is that the devil is always in the details. And the bigger challenge with migrations, why is it not just a simple, straightforward process, is that it's a very sophisticated process with feedback loops. Technical issues confound planning activities. Slower planning creates friction in the company. People start to become uneasy. They start coming up with new requirements. New requirements mean more technical hurdles and so on and so on and so on. And this can snowball easily into multi-month analysis paralysis, which is something we frequently see with larger companies. Or it can just become like a never-ending set of test, find a problem, try to fix, test, find a problem, try to fix, and so on. Some of the most common technical hurdles are downtime requirements, how to minimize or avoid downtime altogether, how to make sure the migration is fast, how to have a backup plan, how to prevent data from being exposed to public internet. For example, you may want to have a virtual private network or VPN or something of that nature. And of course, DynamoDB, MongoDB, Cosmos DB, they are mature databases. They have their own specifics. How many RUs do you need? What indexes do you need to provision on the destination, or do you not need to provision indexes on the destination? What configurations to pick, etc., etc. And obviously, there is physics. That's probably one of the biggest hurdles when it comes to technicalities. You can't move data faster than the network link. You cannot read data faster than the source allows you to read. You cannot write data to the destination faster than the destination can write. And that's a very, very common paradigm when the destination is the bottleneck, because that's the most expensive process in this chain of read, transfer, write. You need to write data to the destination. Database writes are expensive no matter how you put it. Cost by itself is also a consideration. Now, on the process complication, it's a completely different story. Even if you have the best tools and you address all the technical hurdles, you still have concerns around doing the same process and following it to the letter across multiple different environments, maybe multiple production environments, and all of those environments tend to be different in some shape or form. And even after you've done all of this, there's always something new that pops up. And the story that I wanted to share, it was not our customer. It was a customer that I personally worked with a different tool. And on the surface, it was a very trivial migration. All they wanted is to take the deployment piece by piece. It was about maybe 100, maybe a little more than that gigabytes, and move it from one place to another. And that took them over a year, while the original projection was less than a month. Why? Because there were some small things that would pop up here and there. For example, a bug in the migration tool, or they didn't know that certain data types or certain schema requirements were not satisfied, or they wanted to quickly change a type for one little thing. And those things, each one of them is not a big deal, but when they come up, each one of them requires you to redo the whole process, right? If we need to fix the tool or implement a new cool requirement, that means you need to change the code or change the process a little bit, retest it in staging, retest it in load test environment, do a dry run in production, and then you discover something else. And it keeps going and going and going. Each iteration, say a month, 10 iterations easily push you to a year. And that's how those things become longer and longer. What can we do about it? First of all, we need to simplify. My advice is always to simplify as much as possible. If you can do an offline migration, do an offline migration. If you need to do an online migration with a change stream data capture going from the source to the destination to ensure that you'll keep downtime to the minimum, do a test and know exactly how long it's going to take to catch up. Figure out how to minimize that time. Make sure that you know exactly when it's going to land so the people are there and you can do a nice, easy cutover. On the process side, or I guess people and process, I found that customers with a specific dedicated champion for the migration, they tend to move much faster. And it's important that this is a technical person on the team who is serving as a technical project manager or a technical champion. You can call it whatever you want, but their goal, their job is to make sure the migration is moving forward, and that at some point, some new requirement comes up and they can have the authority to make a compromise and say that it's okay, we will just take the hit. For example, we will not do a complete validation of a complete hash-based validation of the whole 10 terabyte data set. It's going to take too long of a time. Let's just validate the subset of data. If they have this authority, things tend to move much faster. The third important thing is to test early with production data. Like I mentioned just a couple of minutes ago, whenever you do production, I'm sure everybody knows that, everybody's familiar with the scenario. Production is at the very least a little different, right? This might be something as benign as a difference in the actual data. For example, you might be obfuscating or reducting PII data when you're moving data from production to staging, or it can be just features that were implemented different, or just bad data in production or staging. It's important that testing on the destination, for example, if we are moving to Cosmos DB from DynamoDB, that we start testing on the destination with production data or a subset of production data as soon as possible, while the migration plan, the final details are still being ironed out. As we will discuss more and more, there is a lot of those final details to iron out. So that will take time, but that should not be a blocker for testing the application on the destination and figuring out all the little edge cases around performance, around integrations with other systems, around cost. The advice number 4 is to over-provision. You don't have to over-provision forever, but you want to over-provision on the destination for the time of the migration. It's very critical because we already discussed the shorter, simpler process is usually a better experience for everybody involved. And the destination is often the bottleneck. So if you increase the capacity on the destination, the migration is cut shorter. For example, on a Cosmos DB NoSQL with 40,000 RUs, 4030 zeros, that's read units per second or request units per second. That translates, roughly speaking, into 10,000 writes per second. That's how much you can do with 40,000 RUs. If you provision 80,000, that means you can do double. That means your migration will be twice as fast. That means you will spend less time waiting for it to complete. And that also means that within the same amount of time, you can do more tests. And that's the last most important advice. Do lots of testing, do lots of dry runs. It should not be a big deal to do a migration if you are preparing to migrate from one production database to another. Right? It should not feel like a big deal, because if it does, there is a very high margin for error. And if something blows up, you will not know what to do. You will not be ready. So it should really be like a very well-planned, very familiar scenario when you are migrating data from point A to point B. Just like cutting files on your MacBook or Windows is not a big deal, right? You just copy files from one folder to another. And that's really the paradox here, that in my experience, a 10-hour migration is a much more complex endeavor than 10 migrations, each of them as 1 hour, right? Because it's just my experience. It's better to keep things shorter, keep them more manageable from the operational perspective. That makes it maybe more boring, right? Obviously, a 1 hour migration is 10 times less exciting than a 10-hour migration, but boring is good when we're talking about production. It's really good when a migration starts on time, when nothing interesting happens for an hour, and then it completes when it's supposed to complete, and everybody just close the war room and go home, and everybody's happy. That's the best scenario here. It's risk-free. How do we get to that scenario? We need the right tool. And in my experience, there are a few specific requirements what makes a good tool for migrations, especially for large-scale production migrations. First of all, you need to have high performance. As I already mentioned, the better the tool is, the faster it can move the data, the less time you spend waiting, the less time you spend planning, the happier the people are. Ideally, before somebody even has a question, hey, how is this going to work if we move the data? You should already have the data in Cosmos DB. You should already have a POC with a subset of production data to show that's how it's going to look. This is what it's going to cost, etc. The other thing is synchronization. If you do want to minimize the downtime for the migration, you need a CDC, a change data capture because if you do the initial data copy from the source to the destination, then you need to transfer all the changes after. Most tools, they don't really coordinate those two steps. So if they even support CDC, it's still on you as a user to find the right time to switch from the initial data copy to CDC and manage that interaction. And in my experience, that's A, error prone, B, that creates delays. So it's important to have a tool that allows you to do this in as streamlined as possible manner. The other two important things are flexibility. You don't want a tool that is too rigid, that it just does things the way it does and you cannot change it at all. Granted, most tools right now are no-code or low-code, so they do allow you to make changes or add new blocks, like, say, Azure Data Factory. You also want, for migration specific, you want validation tools. You want to be able to have more than just a counter comparison, ideally as part of the same package or maybe as standalone scripts, but having a methodology for validations is super important. The next one on our list is visibility. As the migration moves forward, you want to know a few things. You want to know, is it moving forward? You want to know how fast. And once it moves into the change stream data capture, you want to know, is it catching up or not? And when is it going to finish, right? Because if you don't know when it's going to finish, then it's hard to plan. If you don't know if it's catching up or not, because maybe on the production, on the source side, you have ongoing large load, then you might wait forever and you will never reach a point when you can do the cutover. The last, but not the least important point, is reliability. For general data transfer tools, and a lot of people are using ETL tools as part of like their migration approach. It's an important requirement to consider, because a lot of ETL tools, they like for them reliability is nice to have. Let me put it this way. It's okay for an ETL process to be maybe stuck or delayed for a little bit, wait for manual intervention, or just be broken, because you can always restart it. When it comes to migrations, that's a process that you want to be able to rinse, repeat, and do well every time. So you need to be able to have good resumability at both stages, initial data copy and change data capture. And you want to have some backout capability. Whatever form it takes, it always makes people or puts people at ease in the company when there is a backout strategy. Personally, I have not seen a lot of people. I think I maybe seen like once or twice when people use this backout option. But it's even if theoretical, it's a good thing to have, right? Because it makes people more comfortable, more confident. That's important. And it so happens that that's a tool that we are building at Adiom. We call it Desync. And the goal for this tool is to build an out-of-the-box solution that is very easy to set up, does not require any infrastructure or any manual coordination between different components. For example, if you are using Azure Data Factory, like you need to configure it, you need to set it up for migrations. If you are migrating from DynamoDB to Cosmos NoSQL, you need to set up S3 with Spark, and that's a lot of things to do. And we believe that things shouldn't be that complex, especially if you want to keep doing the same thing multiple times as part of a production migration. So we really package this whole sequence of steps as part of one single binary that we call desync. And that's really as simple as it gets, just desync from here to there. We use behind the scenes a lot of things that we just talked about, like partitioning to ensure fast data transfer, seamless switch from initial data copy to change data capture. We support different connectors. We support more than just DynamoDB, NoSQL, and vCore. But specifically for the purposes of this presentation, we are focusing on DynamoDB to NoSQL and MongoDB to vCore. We, of course, have resumability. We have observability via CLI, command line interface, and web interface, some embedded data validation checks. And most importantly, it's repeatability. A lot of users, they are very happy because they can just run this anywhere. It can run on VM, it can run on laptop, and for most use cases, it just works with little intervention needed, and it just does the job. And I would like, with your permission, to show you this, what it looks like. Now, we had two options in full disclosure. One option, I could show you a video. It's pre-recorded, very nice quality, but it's kind of boring. So Jay and I, we decided that for the sake of entertainment, we're going to do a live demo. And that means that you will need to bear with me a little bit as I switch to this other environment. And you will need to bear with some delays here as I show you things. First of all, here are our DynamoDB tables. So we have a few tables here. This is actually healthcare data. It's obviously not real data, but it's very close to what we've seen with one of our customers. I tried to load a lot of it. Unfortunately, S3 loading in DynamoDB is pretty terribly slow. I started it last night. It hasn't fully completed, but we have 3 tables that are done. So they have some records here. You can see these are real tables. I'm not making it up. It's not saved somewhere. I just loaded these this morning, so they have a lot of different values and stuff loaded from CSVs. So we have these tables. Now, what we want to do for this demo, we want to move those to Cosmos NoSQL. And here in Cosmos NoSQL side, we already set up a container, a database. We call it Azure. It has shared throughput. I put it as 40,000 RUs. And when we were talking about over-provisioning, I forgot to mention, but it's very important. For vCore and NoSQL, the over-provisioning strategy is a little different. For vCore, you would just pick a higher instance size, and then when you're done with migration, you would just descale back. With NoSQL, you need to be mindful of those limits. If you put the RU too high, the minimum will change, so you will not be able to go back to, say, 4,000 from 4 million. So that's an important thing. You don't need to go crazy with those things, but that's just something I wanted to highlight. A good rule of thumb is that one write operation on Cosmos DB will cost you anything between 3 to 5 RUs. And in the ideal world, you also want to make sure there is no extra indexes or any other write amplifier on the destination. Anyway, here's our database. So you can see it's a real database, and it has 3 very real collections for our 3 tables from DynamoDB. All of them are empty. I just created them a couple minutes ago. To move those things, we have generally 2 options. One option, we can just export this into S3, move things from S3 to Azure side, import them to Cosmos DB. That's a lot of things, a lot of steps, right? We could use Spark. That's also a lot of steps. We will use desync instead. To use desync, we can download it from GitHub. So it's available as an open source tool. And there are instructions in our docs. You can see them here. This is a quick start specifically from DynamoDB to Cosmos DB NoSQL. I already pre-created a VM. We have a marketplace offering for DynamoDB to NoSQL and for MongoDB to vCore. So this is my desync demo VM that I created specifically from that marketplace offering. It's already set up, and there are 2 things to set it up, right? Provision the VM, log in into DynamoDB, and get these things, the keys, from the NoSQL account, because we need to be able to connect to NoSQL. And this is how I set it up. So here we have our URL and the key for Cosmos DB, and we started the sidecar to connect to Cosmos. And here in this screen, we have our desync command. And you can see the desync command is really as simple as it gets. It's desync And here is our namespace mapping. We do need a mapping because we have one table name on the source, which is DynamoDB, but we have two names, which is the database and the collection name on the NoSQL side. But we can just move multiple of these at the same time. So here's our mapping for prescriptions. Here's our mapping for POE. And here's our mapping for pharmacy data. Then we say we want to see the progress in CLI. We want to put logs somewhere from DynamoDB, and this is just the local gRPC connection to this Cosmos Sync sidecar. And we can kick it off. Again, it's a live demo, so let's see what happens. So first it does the read planning, and here we got some issues. Okay, that's exciting. That's what happens when you get a live demo. I apologize for this. Let's try to do this again. If not, we'll just figure out how to redo it. Swear I tested it before. Okay, then we'll do this. Okay. We'll just do it without the cool progress view. This way we will avoid this error. Again, apologies, those things happen. At the very least, we don't need to debug anything right now.
The demo gods, they give it and they take it away, right?
Yes, it happens. But the logs are self-explanatory. Hopefully you can see them that you have some progress here, and it says that we are moving the data. And here you can see the number of tasks. Actually, let me see if I can restart the thing, and maybe it will start moving now. If not, we'll just deal with this. Okay.
And while this is going on, I just want to remind everybody, if you have questions, please feel free to put them in the chat. Gives you an opportunity to take part in this session. We've got a few questions already, and we'll get to them at the end of the session. So please keep sending it in. We want to learn what you want to learn.
Okay, so I guess we will have to deal with the log-based output. Again, my apologies, folks, but the demo gods, they didn't let us do this today. What we can see, however, is there is a certain number of tasks. So I will talk a little bit about how those tasks come into existence. Dsync does intelligent parallelization on the source when it creates a read plan. And that means that every namespace here, we have three tables, three namespaces. Every namespace is split into a certain number of tasks, and we dynamically decide what the number of tasks should be based on the size. You can also configure the partitioning strategy if you want. So here we have 10 tasks across three tables. And in this simple output in the shell, we can see that we are moving data, we are copying them tasks, and that's pretty much as you need to do as a user. You just lean back and wait for it to finish. An important piece here is once the initial data copy finishes, then Dsync will automatically move into the change data capture mode. So you as a user don't need to do anything. You just need to press Control-C when you're ready to cut over. That's really as far as that goes. And we can see here in our Cosmos DB instance that the data is coming in. You can see already that there are some records here. This is, let me make it a little bigger. So this is the same record that we have on DynamoDB. The only specific thing that you did not see is that I specified the partitioning key on the destination on Cosmos DB whenever I created those collections. And the partitioning key is ID, and it corresponds to the partitioning key from DynamoDB. We very much bring it as is, right? So whatever partitioning key was on Dynamo, it will be this ID. Right? This way we simplify the whole transfer. And that's very much it. We can give it a couple more seconds. Should complete pretty soon. Again, sorry about that snafu. Live demos what can you tell? Blame Jay.
You wouldn't be the first person to do that.
Well, at the very least, I know how to work around that thing.
Fair enough.
So hopefully that makes it a little bit more clear how this whole process works. And the idea that we have here is to make it really simple, because you noticed I restarted desync multiple times, and at no point in time I had to worry about reconfiguring anything or setting anything up. That's really what we are shooting for. We are just making sure that this process is as seamless and as straightforward as possible. Here we are actually already done. So it was like just over 500,000 records actually, so not a whole lot. And we are done. We are tailing the change stream on the source. So now what we need to do, we need to demonstrate that it actually works. So for this demonstration, I will just go into this prescription table. And in this prescription table, we'll create a new entry. How about that? I'm not sure how to do this well, but let's do this. Alex test, that will be our entry, and we will add a new attribute number, value, I don't know, 100,000. That'll do. Let's see it. So now we should find this into our prescription collection. Let's go to this prescription collection here, and let's see where CID is Alex test. Oh, wow, look at this. It's already there. Well, it's supposed to be real time. What it does is it automatically trails the change stream, or however they call it in DynamoDB. I think it's change stream. And whatever changes we get, it sends immediately to Cosmos NoSQL. So that's as real time as it gets in this way. That's pretty much it when it comes to the demo here. So I'll go back to the slides. 1 second. And that's the web view. I didn't show it to you, but we also have that. Now, if you do need our help, you can reach out to me directly. This is my email, or you can reach out to our corporate info at. We have our documentation, which rendered as an unknown link, of course. And there is a GitHub repo that you just seen. So we are here to help. We also have a Discord channel, and we have those marketplace offerings, and we work pretty tightly with Microsoft, and our goal and our primary incentive is to make migrations easier. So I'm here to very happy to answer any questions, any ideas you want to discuss. We have some time.
Yep, we've got a couple questions. And so let's start out with Maxime. Maxime wants to know, is there a basic mapping between the number of app users and database RUs?
Well, I would have to speculate what's behind the question. But if you have an app that uses Cosmos DB, then you need to think not in terms of the users, but necessarily in terms of what those users do.
Yeah, the modeling of the data and the data access methods.
Exactly. So the data access pattern is what counts. And the reason why I'm being intentionally vague here is because sometimes once you start analyzing your workload, you will come to a conclusion that maybe you need to choose a different data model. Or maybe Cosmos NoSQL was not the right thing to use. Maybe you should have used the MongoDB API because it gives you more flexibility. I think it's really important to think not in terms of data models. Like in the database, it's important to think about your data objects. What are the workflows? What does your user do? What kind of data your application wants to store? And then you can figure out what's the optimal access pattern for that within like the databases or a set of databases that you want to use. And your RU can be as, like, for example, if all your user does is like logs in, maybe reads some, I don't know, feed and whatever, maybe sends a couple of updates, then maybe like you can be fine with like 1,000 RUs, maybe even the free tier is fine for you with 400 RUs per second if your users are not very active. Right? It's impossible to map that one-to-one.
So provision on use case and not just what you're assuming traffic could be based on individual users, but more about what are those users going to do when they're actually accessing the data.
Exactly. And auto scaling really helps. In my experience, what I really like about the specifically RU offering, I like that you can auto scale independently, like different containers. So you can say, like, for example, what you've just seen, like Azure database shared throughput, but then for certain containers, I can say I want dedicated throughput, and I can do that. For vCore, you have auto scaling, but it's not instant. So there, it's just like you need to be a little bit more proactive in how you think about the workload.
Got it. All right. Maxime has another question. Should we be running the migration based on the partition key?
Yes, and the answer is absolutely yes. So that's exactly what we do in desync, and that's really the secret sauce behind any fast migration. You need to have a way to split the load on the source, right? And you want to do it on a partition key basis, but for example, we also support like MongoDB sources. And in MongoDB sources, if you don't have a sharded cluster, then you don't have a partition key, so you need to come up with one.
Got it. We've got one last question. If anybody else has one, please feel free to put in the chat. We have a little time left. So I'm not too sure about this, but if we have data in Neo4j and want to migrate to Azure, is Cosmos DB the right choice to be used for migrating the same data? I'm not particularly sure when it comes to Neo4j and that particular graph data.
I'll honestly say that you can have a graph API in Cosmos DB. That's equivalent. But is this the right choice for your use case? I don't think I'm prepared to make such a blanket statement. I'm not getting for this one, and all opinions here are my own. So I really don't know for sure to make a generic statement and answer your question like that. I'm sorry.
Yeah. Sorry. We had our answer. Thank you, Maxime. We appreciate you taking part. So thank you, Alex, for taking part. And I've got someone that's going to help us start wrapping things up. And that is Askia. Hi, how are you?
Good. I'm good.
So we've got a little bit of housekeeping to close things out.
Yeah. Well, once again, as Jay mentioned, Alex, thanks for a great session. And we definitely appreciate feedback from all of the viewers. So if you have a moment, we've put the survey link on the screen, and you just want to reference today's event code, which is 25624. It's again 25624. All feedback is welcome.
Alex, thank you so much. I'm going to go ahead and I'm going to put in the down below the website once again. You can go down there, pointing all the way down. There we are. I'm pointing down towards the URL, adiom.io. You can go check out more about it. And then, of course, you can find Alex on LinkedIn. I'm going to point down below. That's how you can find him. Alex, thank you so much. Appreciate having you here today.
Yeah. Thanks for having me here, guys. Really appreciate the questions and your patience as we were navigating the challenges to the demo.
Absolutely. So, hey, everybody, have a great rest of your June. We'll see you in July for the next one of these. Askia, thank you so much as always. If you would like to be part of this in the future, just like Alex did, fill out the intake form. Let us know what your idea is. We'd love to have you present what you're working on, what you're successful with. Go ahead, show off, tell us. That's what we're here for. But until then, let's give everybody a big wave goodbye. Thank you, everybody. It's great seeing you. Thanks, Alex. And have a great rest of your day. Bye now.
Bye-bye.